So, we're going to talk about trig identities, and there's really only a couple of general things that you really do need to know about it as far as everything goes. So the one of the big things, maybe the biggest thing that you need to know is that you can write everything in terms of either sine theta, cosine theta, or some combination of the two, okay? And that's going to be your big thing. The other thing is a specific trig identity, which I suppose I could go through if anybody wanted to see it, but the identity is that sine squared theta plus cosine squared theta equals 1, and this is what's called the Pythagorean identity for trigonometry. This will get us through quite a few things also. So you want to use these two things in combination, and what I'm going to do first is I'm going to open up a new board here, and we will talk about how to write everything in terms of sine and cosine. Okay? So let's start. We've got sine theta, we've got cosine theta, we've got tangent theta. Those are your three sort of base trig functions, and then we've got three more. We've got cosecant theta, secant theta, and cotangent theta. And sine and cosine, of course, we don't have to worry about because those are already in terms of sine and cosine. But tangent is actually sine of theta over cosine of theta. That's how we define tangent. Cosecant theta is 1 over sine theta. Secant theta is 1 over cosine theta. And cotangent theta is 1 over tangent theta, meaning it is the reciprocal of the tangent. So if you take the reciprocal of this fraction up here, that tells you the cotangent in terms of sine and cosine. So cotangent theta is cosine theta over sine theta. So what you are seeing here is that you can write every single one of the 6 trig functions in terms of sine, cosine, or a combination of sine and cosine. And this is what allows you to simplify much bigger things into these smaller problems that will then allow you to make a lot of sense out of things. For example, I'm just going to make one up here. If I were to give you, let's say, cosecant theta times sine theta plus, let's put in something sort of weird here, plus cotangent theta, something of that nature. Okay, you might run into things like this. What you're going to see is that if I start by saying, okay, I've got this cosecant theta here, And if I were to write that instead as 1 over sine theta and multiply it by the sine theta, and I still got this plus, and then if I were to write the cotangent theta as cosine theta over sine theta, then there are some things that happen rather nicely here that I can work with. Okay, I could do the multiplication in this part here. I could do the multiplication and do sine of theta times 1 is sine theta over sine theta plus cosine theta over sine theta. And you could write that sine theta over sine theta as a 1. However, if you take a look here in the denominators of both, take a look down there, you see they have common denominators already. So it doesn't help you a whole lot. I mean, I suppose one way of writing this answer, and this isn't going to be necessarily our final answer, but you could write it as 1 plus cotangent theta. That's one way of writing this, but I'm going to ignore that possibility because it doesn't really take us to a lot of different places. I'm going to look at these common denominators here, and I'm going to note that because I have common denominators, I can write the top added together. So sine theta plus cosine theta, all of that over sine theta. Now, the question then becomes, is there more that I can do with this? And the answer is not really. I could factor the 1 over sine theta, which is in the denominator here, the 1 over sine theta. I could factor that to the front and then call this sine theta plus cosine theta. And I could look at it that way too. Ultimately, there's no way of knowing which version. I mean, we could indeed be looking back at this version, but we could be looking at this version or this version. And what happens is any of those might wind up being useful depending on what we're going to do with the problem next. For the person who asked about this problem, what I would, or about these types of problems, what I would say is if you write everything as sine and cosine, if you look at these identities here, it will take you very far, because what's going to happen is you're going to have stuff that cancels, kind of like this one here. This idea here can become a 1. You're going to have a bunch of stuff that cancels like that and allows you to do all this, and simplifies it by quite a bit. So my advice is always look at these trig identities here. And then the other thing that I would say, let me look at one more little scenario here. The other thing that I would say is the Pythagorean identity. Let me clean that up a little bit. The Pythagorean identity, sine squared theta plus cosine squared theta equals 1, is something that is very manipulatable, and something that winds up being highly useful also. You're going to run into this quite a few times as you work through these types of problems. And you want to note that you can do a couple of simple algebraic things with this that make it even more useful. So I'm going to do those down here. For instance, if I were to subtract the sine squared theta on both sides, I would get that cosine squared theta equals 1 minus sine squared theta. So then, anywhere where I see a cosine squared theta, I could substitute in a 1 minus sine squared theta. And anywhere where I see a 1 minus sine squared theta, I could substitute in a cosine squared theta. As an alternative to this, there is the other side of it. If you have that same identity, and instead you subtract the cosine squared theta, squeeze it in there. It doesn't look real nice, but I squeezed it in there. Then you get that sine squared theta equals 1 minus cosine squared theta. And so then you can make the substitutions either for sine squared theta becoming 1 minus cosine squared theta, or the other way around, 1 minus cosine squared theta becoming sine squared theta. So that makes this a pretty useful thing here. There is one other thing that I want to talk about with these two, and that is if you have, let's say, for example, that you have cosine squared theta equals 1 minus sine squared theta. Hey, Mo. Awesome. Thank you. I'm glad it's working a lot better. I am, in fact, talking about trig identities right now. I am recording it, so I'll be able to put it on YouTube. You'll be able to see the entire video later. But what I'm talking about right now is the Pythagorean trig identity, which you can see at the top here is sine squared theta plus cosine squared theta equals 1, okay? And I have manipulated it down here to be cosine squared theta equals 1 minus sine squared theta. All I had to do was subtract the sine squared theta on both sides to make that happen. And now, what I want to show you is if you were to, let's look at the right side here. Let's say that I factored a negative out of there. So I divide everything essentially by -1 and put that negative or that -1 to the outside. The 1 goes from being positive to negative, and the negative sine squared theta goes from being negative to positive. So you get a positive sine squared theta and a -1 by doing that, okay? And so if you were to look at it this way now, and I haven't done anything to the left side, notice that. If you do that, what you allow yourself to do is say, well, okay, if I multiplied both sides by a negative, then I could say that negative cosine squared theta is equal to this stuff inside the parentheses here, so it equals sine squared theta minus 1. Okay? So what that allows you to do is to look at sine squared theta minus 1 and say, oh, well, If I factor a negative out of that, then the -1 becomes positive, so I get +1. The sine squared theta, the positive sine squared theta, becomes negative, so I get minus sine squared theta. And since this right here is equal to cosine squared theta, as has been noted up there, then this must be negative cosine squared theta. So you have to keep that in mind when they're reversed like that. You have to be able to see that you're off by a negative and see that change. And of course it works for 1 minus cosine squared theta equals sine squared theta as well. Okay, so just a tiny bit of a review here. Write everything in terms of sine and cosine and keep that Pythagorean identity in mind. Okay, here's all of the 6 trig functions written in terms of sine and cosine so that you can change everything, and that is one of the first things that you should do, is to change everything. Okay? Finally, well, thank you. Anyway, finally, the last thing is, and there's a bit of an example there, and how I went through it. I didn't have an actual problem to work, so I just kind of made one up. And then you can look at this Pythagorean identity and use that. My last piece of advice, and this is just kind of in general, is every minus, and it would have helped us down on this last screen too, every minus is something that can be written in terms of plus negative. You can change every minus into a plus negative, and that will help you keep track of what's positive and what's negative. So I am going to be done with this set of problems now. That is our trig identity stuff.